Find the slopes of the tangents from 0, 0 to the circle x squared plus y squared minus 20x minus 20y plus 196 equals 0. I'm going to show this circle in GeoGebra, but first of all I just want to note the centre and radius. To get the centre we have the coefficients of x and y and change the sign, because remember the general form of a circle is x squared plus y squared minus 2hx minus 2ky plus c equals 0. So h is the x value of the centre. So minus 2h equals minus 20, from which we get h equals plus 10. Minus 2k equals minus 20, so k equals plus 10. So we just have these coefficients, change the signs. Now to get radius we use this formula here. So h is 10, k is 10, c, the constant in this equation, is plus 196. So we get root 100 plus 100, which is 200, minus 196, that's root 4, which is 2. So we can enter the circle in here, and its centre is 10, 10. So we have to zoom out here. So we're interested in the tangents to this circle from the point 0, 0. To show the tangents here, you can just type in the word tangent, square bracket, the name of the point, which is A, and the name of the circle, which is little c. Now we know that to get the slope of a line, say this line here, we have to get the angle measured anti-clockwise from the positive x-axis to this line. So we have to get this angle here. Let's suppose that this angle is A. We know that the slope is given by the tan of this angle. The tan is just opposite over adjacent if we construct a right angle triangle. So, we could take this side as the side opposite angle A, and then this side here would be the adjacent. So anyway, that's just the meaning of the slope of a line. We always measure anti-clockwise from the positive x-axis. So we can do this problem by getting angles. We know the coordinates of the centre of the circle, so we could consider the line through 0, 0 and the centre of the circle. The centre of the circle has coordinates 10, 10. Now we can find the slope of the line joining 0, 0 and 10, 10, because we have two coordinates on this line, so we can actually find this angle. The slope of this line is actually 10 divided by 10. So that's just y2 minus y1 over x2 minus x1. 10 divided by 10 is 1. So the slope of a line is the tan of the angle measured anti-clockwise from the positive x-axis to the line. So if the tan of angle B is 1, which I'm calling this angle, then B is inverse tan of 1, which is 45 degrees. We can also see that this triangle is clearly an isosceles right angle triangle. So the two angles in this right angle triangle are the same, and they must add to 90 degrees, so they're both 45 degrees. You could see it that way too. Now to find angle A that you saw earlier, this angle here, we need this angle to get the slope of this line. We need to get this angle in here. We take this angle from 45 to get this angle. So how do we find this angle, which I'm calling C? Now we use the fact that a line from the centre of a circle to the point of contact of a tangent to the circle is perpendicular to the tangent. So C is an angle in a right angle triangle. Now we know that the radius of this circle is the square root of 4, which is 2. So C is in a right angle triangle. The side opposite C in this right angle triangle is 2 units long. We can also get the hypotenuse of this right angle triangle. That's this line here, the distance of 0, 0 to the centre of the circle, 10, 10. So let's get the distance of 0, 0 to the centre of the circle, 10, 10. Well, we just use the distance formula. We get the the square of the difference in the x values. So we have 10 minus 0 squared, well that's just 10 squared. Then get the square of the difference in the y values. That's another 10 minus 0, or 10 squared. And we sum these squares and take the square root. That's just essentially Pythagoras' theorem. So, you know, this line here is the hypotenuse of a right angled triangle with short sides of length 10 each. So, the sine of angle C in this right angled triangle is the side opposite angle C, which is 2, divided by the hypotenuse, which is root 200. From this we get C equals 8.13 degrees. So now at last we can get angle A. We take 45 degrees and subtract C, and we get 36.87. So then finally now we can get the slope of this line. As we saw earlier, the slope is the tan of angle A, and if you use many decimal places you'll actually get 0.75. So now, what about the other line? What about the slope of this line here? Well, C is the same in both of these right angled triangles. These two right angled triangles are congruent to each other. So I'll just call this angle C. It's 8.13 degrees. So we can get the angle that this line makes with the positive x-axis quite easily. So we want this angle here. We have to get the tan of this angle here to get the slope of this second tangent. So I'll call this angle D. To get D is easy. We take angle B, which is 45 degrees, and we add on angle C, which is 8.13 degrees. So now we can get the slope of this line. We just get the tan of angle D. Now you see here you get 1.333. It looks like it's 1.33 recurring when we allow for rounding error. So this value here looks like 1 1/3 or 4/3.